Hello. Yeah. Yes. Good morning, everybody. Okay. In the previous class, we have discussed about the topics. Okay. That is in the third module. Okay. We have discussed various topics. Like I think up to 3D, three-dimensional transformations, file transformation, OpenGL geometric transformation functions. And we have studied up to this point. In, module 3, you see module 3, see two questions I can see you what how you can prepare is definitely you have to attend the first bit, I mean the first question from the module 3. Okay, where I think I already discussed what is clipping window normalization, viewport transformations, clipping algorithms, important clipping algorithm, that is Cohen-Sutherland for 2D point clipping. Okay, or 2D, so for 2D point clipping I think it doesn't have that much of significance. I have already discussed, that is Cohen-Sutherland line clipping algorithm along with some problems. Okay, please do go through that. That's a must question. Okay, in third module, must question. Definitely an algorithm can be asked, or a problem will be given. You have to solve that particular problem using the algorithm, or maybe program is also asked sometimes. But it is a must topic here. Then we have polygon fill area clipping. We already discussed. Again, clipping four steps are there. We have to follow those steps for any given polygon. Okay, so some example problems are there. Some polygons exercises and some other problems that are there in the previous question paper. All those things I am going to share with you people shortly, so that you can use it. Okay. Hartman, that's what clipping algorithm. Then after that, 3D transformations. So basic, if you know what is 2D, two-dimensional transformations, three-dimensional can be automatically understood. Just we have to upgrade, just we have to add one more dimension. Okay, and for homogeneous representation, you have to add one more extra column, extra row to have homogeneous representation from 2D to 3D. Okay, so we have done. Okay, up to this point. Okay, and but still, there are some topics and third module just be covered, which will come in second bit, in second question. But what I suggest you people is always target the first question. Okay, so for second, I think we have the color models, properties of light, RGB and CMY color models, illumination model C, and all these concepts are there are a lot of physics concepts which you have already studied in your plus 2. Okay, I hope you all have studied optics, right? So you have discussed, you have already studied various concepts related to light and light theory. Okay, so which you're all already familiar with. So what I just suggest is how we are going to use these concepts in OpenGL. Okay, how we are going to model, how we are going to represent these concepts with respect to OpenGL application development. Those things we are going to discuss. Okay. See, nothing much. See, if you go to the textbook, there are a lot of things. It is quite complex for you people. Even if in the notes, it's you may feel it quite complex. But what I suggest you is just you prepare for straightforward questions, especially from this particular part. Okay, you just prepare for straightforward questions. Example, what is RGB, what is CMY color models? You should be able to explain what is RGB, what is CMY, and what are the different illumination models that are there. We are going to discuss those models. Okay, and different light sources. Okay, and then what is ambient light, diffuse light, spectral light, and another important concept is the Phong lighting model. Definitely, the Phong model, what you can see, it is called Phong lighting model. Okay, that is based on these four properties. Okay, ambient, diffuse, reflection, specular, and those are the concepts here in this particular thing, which will be asked quite frequently in the question paper. So we'll discuss that. Okay. So what I suggest you people is, see, what I have to tell you is, instead of reading in depth for these concepts, better you just prepare for this straightforward questions like a definitions. Okay, that will save your time. Okay, because here it's difficult to convince you people with all these concepts. Okay, in the field of classroom teaching, definitely that is different. But here I should tell you the strategy how we can prepare yourselves, how you can prepare yourselves to attend these questions. Okay, so if any one question you are attending, my suggestion is always go for the first question. Okay, first question will come up to this point. up to 3D transformations. Okay, now we'll see what is there. So we're talking these colors. So what is color basically? Now you all know already. Okay, what exactly is a color? See, color according to the physics is nothing but light, right? Light is nothing but it is a color because we can see that. Okay, because you know what is the electromagnetic spectrum, the visible light. Okay, that range of visible light, okay, that contains so many different wavelengths. Okay, from 350 to 780 then. And within that range, whatever that is visible, that because it is visible light, the light is nothing but a color. The color is nothing but a light. That's what it is. Okay, so that concept we are going to use in OpenGL. Okay, whenever we say we're going to put some light onto the picture what we have drawn, then basically we are putting some color onto it. That's what we do. Okay. So here, what I want to discuss is basically we can see or observe the color. We can identify the different colors. Okay, in a daylight, is because our human visual system is made such that it is made up of some sort of cones which are which can identify three basic colors. Okay, the RGB, the three different cones. You can see. I hope these concepts you already discussed. You must be knowing in your 10th and plus 2, I mean 12 classes and all. Okay. So these cones are basically responsible for our color detection. Okay, of our human visual system. You know all these concepts. So that's why we always say the RGB as a basic or primary colors. Okay, of any color model. RGB colors, because using these three colors, by mixing a proper proportion of these colors, we can generate any different number of colors that is possible. Okay. So as far as color formation is concerned, we can use two approaches, color formation approaches, that is additive color and the subtractive color. Okay. So you can see here what is additive and what is subtractive color. Okay. See, additive colors, again, there is a lot of difference between both additive and subtractive based on its applications and all. Okay. For additive colors, the basic colors are red, green and black. Okay. When you mix the proper proportion of all red, green and black, all the maximum proportion, if you mix it up, so the color what you're going to get is the white color. Okay. And in case of subtractive color, so if you mix a proper proportion of so here the basic colors are the complements of RGB. Okay, that is RGB are the basic colors of additive color model. But in case of subtractive color model, we use can, magenta and yellow. Okay, can, magenta and yellow, which we call it as the primary colors, where when you mix up these colors, basically what you're going to get is a black color. In case of subtractive color model. So as far as applications is concerned, you can see CRT is one example of additive color where primary colors are added together to give the new color. Okay, and other examples are projectors, lights, these kinds of things. Okay, then. Where the subtractive color models are used, subtractive color systems are used for printing, where we can see nowadays there are a lot of flux boards and boardings across the city, where that is printing of that particular thing physically, printing of the color, okay, on a surface that is by nature which is white. Okay, means if you want to take some printout from your printer, what you're going to do is you're going to take one white sheet and take the printout. So that is putting some color on a white surface, white background. Okay. So that's what is subtractive color model. Okay. So that's what is followed for flux printing and other commercial painting and all those things. Okay. That we call it as CMY color model, subtractive color model. is also called as same bicolor model, where we primary colors are can, magenta and yellow. So you can see what is the RGB color model. Okay, like you can see here, whenever we use the RGB color model, you can see that we are using the different buffers, three different types of buffers, okay, to store the details which we have already discussed in the class. You must be knowing where if you use a particular a memory size, okay, to store the details of one pixel. You know, one pixel can accommodate some number of bits. If it is 24, then all those 24 bits are divided equally among the three color components, red, green and blue. That is 8 bits per one color. Okay, so it is like that. Okay, this is just a abstract representation how a RGB color model system will work. Okay, so one pixel each pixel should be able to accommodate three color components. It is like that. Okay, next is as I already discussed with the people. This is a basic and very common concepts. You can just go through in your feet, and just definition. This definition is enough for you people. That's how you have to understand. Okay, and the natural technique is to use the color cube to specify color components as numbers. Okay, that's what you see. And according to the OpenGL, how we define color is, see, color is represented by an object called color cube. Okay, for a color cube, where color cube is exactly built around the coordinate axis x, y and z. Okay, and every values or primary color values are normalized between the range of 0.0 and 1.0. Okay, you know already. So in OpenGL we use the color cube as follows. So we use the function that is GL color 3f. So that is which sets a drawing color, which I already told you people. Okay. So it takes three parameters. Okay, that is x, y and z. Okay, you can see here x is 1.0, y is 0.0, z is 0.0, which means this particular function call will set the drawing color as red for your program. Okay. So using 3f that you know already, okay, because you can pass identify float values or these values with other data types as well. Now we shall there is another function called, other model called full color, is RGBA system. Okay, RGBA, or that is clear color function, where the fourth component is called as alpha component, which you know already. Basically, what alpha defines is either opacity or the transparency. Okay. And again, that is the values are also range from 0.0 to 1.0. Okay. So 0.0 is fully transparent and 1.0 is fully opaque. So what is transparent, what is opaque, you will understand once you start discussing the material properties or surface properties functions available in OpenGL. Okay. So you can see the function that is GL clear color function that will set the background color actually. RGBA, alpha component. So what are the properties of light? So these are the concepts which something which you have already discussed. Okay, you can go through this lot of videos on this. Okay, and but what you have to prepare for is just some definition. Okay, what are different properties of light? Okay, that you can write about the electromagnetic spectrum. Okay, what is visible light? Okay, then you can see that what are the things that will be existing in the light, is psychological characteristics of the color. Okay, then you see different properties like, okay, Okay, saturation properties, the chromacity, what is the brightness, okay, the psychological characteristics. Okay. Now, color models, that is primary colors, again the same concepts, okay. The primary color model and secondary color model, okay, which you already discussed. Secondary color model is nothing but that complementary color model. So this is color cube representation. Okay. So this is what OpenGL basically refers to. Okay. So you can see at the origin we have a black color. Okay, it's the origin of our of the coordinate system of color model. Okay, where this cube. Okay, and all the values are normalized within the range 0.0 to 1.0. Okay, so you can see here the red, green, and blue are three primary coordinates. What you can see here, three important colors. Okay, and every value here is normalized within the range 0.0 to 1.0, and you can see this dotted line that connects, okay, the origin to the top right of the front face of this particular cube. Okay. So as you move on this particular line, as you just image. Okay. Now, as you move along this particular line, okay, from black towards white, okay, this is a line that connects from the origin to the top of the right corner of the front face of this cube. Okay, this is on this line. As we move along, then we are able to generate every color from starting from white to black. In that, every possible colors can be generated. Okay, that's what is the value of X, Y, and Z or RGB color component values what is specified. Okay. So this is called color cube representation. So it's very important. Okay. And, CMY and CMYK color models. CMY, CMYK is that again complementary color models is to so why CMYK? This is CAN magenta yellow used for hard copy devices such as printers and plotters. Okay. Again, as I discussed, that is physically, putting the color on the white surface. They use CMY color model. Okay. Again, this color cube, what you can see here is the CAN color cube representation for CMY color model. Very similar to RGB model. Here, the primary colors are CAN magenta yellow. Instead of red, green, and blue, here we have CAN magenta and yellow. Okay. It is like that. So, what is CAN color? It's combination of green and blue that you should know. Okay. Like this. In the magenta is a combination of again other two colors. Okay. and yellow is combination of green and red. I think is red and green, okay. Like that. See, because CMYK color model is it's nothing but the CMYK color model itself. But the only thing is here when you mix these three component colors, three primary colors here, you are not going to get the exact black. So to get that exact black, you have to add some quantity of some other color. Okay. So that's why you call that KK component is used to bring that exact black color. Is a black color parameter. Yes. Okay. Just go through that in your free times. These are all very general concepts which you have already discussed, which you already studied. Okay. Illumination models. Okay. See, entire thing of producing the image is just a combination of illumination and reflection. Okay. See, illumination means, see, once light falls on a particular material or an object, then what is reflected is what we are seeing. But what is reflected depends on material surface properties. See, if a light falls on the glass, reaction is different. A light falls on a wall or something, the reflection is different. Light falls on the wood, the reflection is different. Like that, the property, what is the surface property of the material, plays a very vital role as far as reflection of the light is concerned. So it is like that. Okay. So in that sense, there are different types of light sources are there. Okay. Just you can go through that. And, the point light source. What is the point light source? Okay. A point light source is nothing but it is the light from one particular source, which is a source which is very sharp and which falls on one particular point on the object. Just a minute, I'll be back. So you can see here what is a point light source. Next is a distant light source. So point light source, that is single ray of light, okay, falling on the particular object and expanding in different directions, okay, with particular direction and velocity. Similarly, distant light source, okay, you can see here distant light source, okay. Example, okay, where from the particular point, okay, for example, the sunlight falls on the earth, okay, at every point if you measure, the sunlight is always constant, it is same, right? So there is no any variation in the brightness or any other properties. So these kind of common things are there which you have to understand the definitions, okay. That is attenuations, you know what is intensity attenuation is this signal distribution. Signal disturbance and okay, then other properties, spotlight. This spotlight is example of a laser light or something. The properties. Okay, like this. Just go through these different properties and different illumination models. Just try to understand what is the definition. Okay, that's it. Okay, next different illumination models. Ambient light. Ambient light is less like a surface light, or light available within a room where there is a bulb that is fixed and you can see that whatever the visible light that is there is an ambient light. Okay, it's just a light in a moderate environment. Okay. Diffuse reflection. You just go through this all the concepts. Just prepare for the definition. I don't want to get into the definition of all those things. And that requires a classroom help so that I can explain this concept. So a lot of preliminary things that has to be done actually before I start this. But here in the online it is not that possible. So I just only can just tell you the strategy how to handle how you should prepare for these sort of topics. Okay, form model. Again, it is a model that is one that what we use, okay, to generate the colors and light define the light and color properties in OpenGL. OpenGL matrix stacks. As I always I used to tell you that okay, OpenGL, everything that is maintained in OpenGL is only through the matrices. Okay, any object that is visible on the monitor is basically a result of some matrix that is always there. Okay, so what are the important matrices? Always the model we use the important matrix, model and view matrix. Okay, and there are certain functions in OpenGL with which you can at any point of time. Okay, and the OpenGL is going to maintain its own stack as well, where it is going to store all these matrices. Okay, and some functions to get the details of that particular stack. Okay, to find how many matrices are there in the stack currently, you can use the function GL in teacher. It is model view stack depths, number of matrices. How in that? So this function will return what are how many matrices are there currently in the system stack. Okay. So push matrix and pop matrix are the two important functions that we use in order to manipulate the contents of the stack always. So push matrix function, see whenever you define this function, you go on defining the next subsequent line of code. So whatever you write, that is pushed onto the stack. Okay. So this push matrix function, what it will do is it will once this function this particular function is called, okay, then it creates a pointer to the current top of the stack, and subsequently after this whatever the code you write, okay, that code is being put onto the stack, and the pop matrix is a function that is going to bring that particular contents back from stack to the program or execution, I can tell. Okay, so that is done by using the pop matrix function. So push matrix function, once it declares, it points to the current top of the stack, after which whatever the functions or the code you define, after whatever that follows the GL push matrix, everything is put onto the stack. Okay. So once GL pop matrix is executed, then whatever that is there in the stack will come out in the fashion that you know, that is last in, first out, or first in, last out, whatever it is. Okay. So this is about this module 3. So only this much is what we can do here. Okay. Now once the class is commenced, definitely on a whiteboard, blackboard teaching, which again we are able to discuss all these concepts. So here it's quite difficult to convince the people, okay, with all these concepts. So with that I'm going to conclude the module 3 for you people, okay, which I think up to I don't think you'll be having any difficulty to understand up to this particular point, that is from the clipping to transformation functions, color models and other things. For these concepts, just prepare for the definitions and straightforward questions. Okay, that's what is my suggestion. Okay. With that we finish module 3, and in the next subsequent classes we will be discussing about module 4 or probably module 5. I will let you know now. Okay. Fine. Okay. Thank you.